at the number 6, there is the amino group, right? In the case of guanine, at number 2, there is the amino group. And number 6, there is a keto group. In the case of pyrimidine, this is the structure of the pyrimidine. It starts from here 1, 2, 3, 4, 5, 6. And the bases include cytosine, thymine, and uracil. Okay? In the uracil, there are 2 keto groups, 1 and 2. In the cytosine, there is a 1 keto group and 1 amino group. In the thymine, there is an extra, is similar to uracil, but it has 1 extra methyl group. Now, what is important here to understand, to know? The important thing is, in the purine, number 9, okay? So I'll talk about why it's important, the number 9, the nitrogen number 9. And in the case of pyrimidine, nitrogen number 1 is important. Now, there could be the pentose sugar. The second one is the sugar, right? The nucleotides. Base, I talked about base. The next one is sugar, and which is pentose sugar or ribose. In the case of ribose, in the DNA, so this will be deoxyribose. In the case of RNA, which is ribose. So this is the structure which is cyclic form. Is the similar, right? Like the hexosugar or glucose, the same. And if you look at here, this is the structure of D-ribose. 5 carbon sugar, 1, 2, 3, 4, 5. And the ring which is formed from keto group, right? Aldehyde group from carbon number 1 to the carbon number 4, the hydroxyl group of 4. This is the ring structure. Now, if you notice here, there is a 1 prime, 2 prime, 3 prime, 4 prime, and 5 prime. So what is the reason for this? Why not 1? To differentiate from the base. So base is numbered as 1, 2, 3, 4, right? To differentiate the base with the ribose, so we use 1 prime, 2 prime, 3 prime. So if I say 1 prime, it should be from the pentose sugar or ribose. And one of these things is the 2 prime in the ribose, which is hydroxyl group, right? There's a hydroxyl group, which is replaced in the case of DNA. And because of this, could be the DNA is more stable, yes, which can be passed down to the offspring, generation to generation. So in the case of RNA, which is 2 prime, there is a hydroxyl group, which is most likely is very reactive, and they degrade very fast. So that's why mRNA degrade very fast. However, the DNA, which is very stable. And for the, as I talked about the carbohydrate, there is a glycosidic bond. What is the glycosidic bond? The bond between carbon number 1, right? The anomeric carbon, right? Making a bond. So in the case of this number 1, which is number 1 prime, right? In the ribose, this carbon number 1 or C1 can form a bond with the purine or pyrimidine bases. Okay? In the case of pyrimidine, if it is the pyrimidine ring, so there will be a bonding between C prime of the ribose sugar with the N1 of pyrimidine, the nitrogen N1. Okay? And in the case of purine, the bond will be N9. So that's why I said to you, this is important. You have to remember. In the case of purine, N9. In the case of pyrimidine, N1. forming a bond with the C prime one carbon of ribose, and this is known as glycosidic bond, right? And if you look at here, there is a beta end, right? Why is beta? Because this hydroxyl group above the plane. So now we are familiar with the beta and alpha, right? So in the case of beta, that will be above the plane. So this kind of bond, which is known as beta and glycosidic bond. Now we need the third thing. So what is the third item? The phosphate. And this phosphate group is attached to the 5 prime of a ribose, right? If I go back here, so what you see here, this is the ribose, right? And 5 prime end of a ribose sugar, there is the hydroxyl group. In this hydroxyl group, the phosphate group is attached. Okay? Is clear? So now, base, sugar, and phosphate, doesn't matter how many phosphate. It can be 1 phosphate, 2 phosphate, or 3 phosphate. This is known as nucleotide. If I write nucleoside, that means base and sugar without phosphate. 2 things, right? Base and sugar known as nucleoside. Base, sugar, and phosphate known as nucleotide. Now, if we look at the whole structure of nucleotide, what we will see? I cannot see this one. This is useless, right? So this is the base, and this base is purine base, right? And this is known as adenine. So adenine forming a bond with the ribose, okay? 1 prime and N9 through N9, right? 1 prime with the N9, and there is a phosphate attached to the 5 prime of the ribose sugar, and this is the nucleotide, and this is named as specifically deoxyadenosine monophosphate, because there is only 1 phosphate. If 2 phosphate here, name it deoxyadenosine diphosphate, or 3 deoxyadenosine triphosphate. So this way we name the nucleic acid nucleotide. Now I am giving you some examples of those are the nucleotide or nucleosides? Nucleoside, because there is no phosphate group. So those are the nucleoside. So for example, this is adenosine group, adenosine, and which is purine. And the bonding between the sugar and the base N9 with the C prime 1. In the case of pyrimidine, that will be C1 prime with the N1. So we can write the structure of cytidine, guanosine, and uridine. So if you look at here, all this pyrimidine forming a bond with the C1 prime and N1. Those are the glycosidic bond. Now, there could be more than 1 phosphate group. So for example, here showing here nucleoside triphosphate. This is the nucleotide. We can name it as nucleoside triphosphate. And in that case, there are 3 phosphate group, 1, 2, 3, alpha, beta, and gamma. The first phosphate, which is attached with the 5 prime carbon of the ribose sugar, which is known as phosphoester. Okay? and rest of the two phosphate group connected with the phosphate. Those are known as phosphoanhydride. Okay? There are two phosphoanhydrides and only one phosphoester. So it's like similar to the esterification. Phosphate with the hydroxyl group of a carbon. Okay, 5 prime. Is that clear? No? Oh, you already know, right?
No.
So there are 3 phosphates in a nucleoside triphosphate group. First one, which is directly connected to the carbon number C5 prime, is known as phosphoester, and other two, those are known as phosphoanhydride. Now, we can name this nucleotide or nucleoside. So if it is nucleoside, that means base and sugar, nothing else, okay? So if there is a one phosphate at the 5 prime, and that is, for example, adenosine monophosphate. If there are 2 adenosine diphosphate, if 3 adenosine triphosphate. Now, these are examples of nucleoside and nucleotide. Okay, so the base and sugar plus base and sugar is a nucleoside, and yeah, one of the example for deoxyadenosine. And this example is deoxyadenosine monophosphate. There is only one phosphate group, and this phosphate is phosphoester group. And if I put another phosphate group, that will be phosphoanhydride group. Now, here are the many examples for the purine nucleotides. Purine nucleotides such as, it can be adenine or it can be guanine, right? And pyrimidine can be cytosine or thymidine. And in the case of RNA, that can be uracil. Now, if there is a one phosphate group, we can write deoxynucleoside monophosphate, or nucleoside monophosphate simply. So in the case of DNA, RNA, so in the case of DNA, we write deoxy monophosphate. In the case of RNA, we can write nucleoside monophosphate, or 2-phosphate nucleoside diphosphate, or deoxynucleoside diphosphate, or nucleoside diphosphate. So similarly, 3-phosphate deoxynucleoside triphosphate, or nucleoside triphosphate. Now, so I mentioned about the nucleoside and nucleotides. Now, in the DNA, how they are arranged? They form a chain, right? Polymer, right? So the one nucleotide, then another nucleotide, and this is a kind of chain. How the chains are formed? If we look at here, this is the structure of a nucleotide at the top. And I mentioned at the top, which is 5' end. So if you look at the text, you'll see 5' to the 3' end. Okay? So if you see any structure of a denucleotide or the DNA, you'll see 5' on the left side and 3' on the right side. Okay? So what you'll see, what is the speciality of this? The 5' end, if you look at the 5' end, there is a phosphate group. Okay? So which one is the 3' end? So 3' end, which is hydroxyl group of a ribose. Okay? So this 3' end, which is free. Okay? And in between two bases, there is a bonding. So this bonding is, what bonding? This is the phosphate bonding, right? This is the